Uh, Hello and welcome to the engineering mechanics. This is the first lecture, so we are going to start the basic introduction of what this course is about and what we are going to study and cover in this complete course. So let's get started. Course consists of two major sections. One is the statics and the second one is dynamics. So just to have a general idea of what both are, the statics is completely dealing with the systems in equilibrium, and we already know the equilibrium is some when a body or a box, as you can see, is either completely at rest or it is moving at a constant velocity with zero acceleration. So we know this equilibrium consists of whether the body is completely at rest or not, and if it is completely at rest we would call it the body is in equilibrium. And if the body is moving and it is moving with the constant velocity, that means the body is still in equilibrium. That means the net force is applied on the body is zero and it is not able to change its velocity, so it's moving with a constant velocity. Here I have shown both the cases where the case 1 shows the body completely at rest, while case 2 presents the box moving with a constant velocity. And in both the cases, for example, in case 1, we see there are certain forces applied. So there is a guy pushing this box toward the right side, and opposite to that, there is a frictional force that is trying to resist its motion. Similarly, there is a gravitational force applied downward, and in response to that, reaction force, which is the normal force, is applied upward. So overall, the forces are balanced, and the body is still completely at rest. Even multiple forces are applied on the body. So this is the first case. In the second case, we see that there is a gravitational force, there is a normal force, which is the reaction to the gravitational force, and there is a guy pushing the box, but it's still moving at a constant velocity. If that is the case, we would call the body to be still in equilibrium because the guy is not able to either stop it or at least change the velocity. So it's still moving with a constant velocity. So the body would still be in equilibrium. There is so if these two cases occur, we say that it is the power of statics, or the body is completely in equilibrium. So either it is completely at rest or it is moving with a constant velocity. There is a third case where if the forces are applied, you see the forces are applied in the opposite direction. They might be equal. If the forces are equal, we will say the forces are balanced, but they are applied at a different location on this body, which is not moving the body from one place to another, but it is actually rotating the body about a certain axis or a certain point. So the body is no more at rest, it is rotating about a certain axis. So there is a third case where the body may not be in equilibrium, and that is when the moment or torque is not zero. So that constitute the main three cases of our statics, or which we will study in static. One would be the completely at rest, one would be moving with a constant velocity, and third would be that the torque or the resultant torque would be equal to zero, or resultant moment would be equal to zero. Here is the sum up of those equations. So either you have the sum of forces equal to zero, and the sum of moments is also equal to zero. So if these two cases are achieved by a body or a system, you would say that the body is in complete equilibrium. For 2D problems, we have two axes, one is x and one is y axis. So the sum of forces in x, sum of forces in y must be zero, and the sum of moment about just one point, let's say point O, in that system would be zero. For 3D problem, you have the third axis, which is z, and your forces in x, y, and z must be equal to zero, and the moment about x is y, about x is z, must be equal to zero. So if these cases are achieved for 3D problems, you would say the body is in complete equilibrium, and we will deal with them in the statics part. If a similar case for the 2D problems, if these are achieved, we would say the body is in complete equilibrium, and we will deal with it as a static problem. So as a general idea, we see that the statics is a branch of mechanical engineering in which or engineering mechanics, in which forces uh, are analyzed and their effect on the bodies are measured, where the bodies are in complete equilibrium. So in this case, we see the statics deal with the forces on the bodies, or the effect of the forces on the bodies when the bodies are in completely in equilibrium. Uh, Now, the problems that we'll be dealing with in the statics are mainly something like this. For example, if you see this bridge and there is a vehicle moving on it, and there is a weight of the vehicle applied downwards. Similarly, there are multiple strings attached to the truss of the bridge. So these are some kind of problem that need to be solved, that what would be the resistance force or the tension produced in each of these strings. So this is just a sample problem. Similarly, if you look at this crane, it's lifting certain weights, so we may want to calculate that if the body has a weight of something, then how much force you need to apply to lift it up, or something like that, or whether this crane will be able to lift it or not. So, and then next problem can be like, for example, this train. So we have a certain weight and there is a friction between the rails and the wheels of the rail, so we have to measure whether our force of this buggy would be able to pull the whole cart or not. So these are kind of a basic problem that we will be dealing in the statics. And similarly, let's say, for example, a certain force of liquid is applied on a dam. uh, so what would be the response of the dam, and similarly how the resultant forces produced in the dam. Most of the problems will be related to the cables and strings, and the trusses as well, so that would be for the bridges kind of. So this again just a sample of what we are going to solve in this course. Now the second part, which is the dynamic, that's completely opposite of what we said in statics. So statics is completely equilibrium, but in dynamics we deal with the bodies that are not in equilibrium. So they they are not completely at rest, and they are also not at a constant velocity. So if the body is at rest, it will not be completely at rest. It will be either moving from rest to motion or from motion to rest. And if it is moving, then it will not be moving with a constant velocity, and the velocity will be changing. So it will be kind of producing an acceleration. So that is what we are going to study in dynamics. For instance, if you look at this guy, he's trying to throw a rock above this building. Now there are two states. There is the initial state when the rock is in the hand, and then the second state where the rock falls on the surface and it comes to rest again. So those two states, when the rock is in the hand, or secondly the rock comes back to rest, those are kind of a static cases where there is no net force applied. But when the guy apply an extra force to throw it up, that is a kind of a net force applied, and the body starts its motion from rest to becoming some gaining some velocity. So that's kind of creating an acceleration. Throughout the mid-flight, there is a downward force applied in the whole flight. So there is a kind of gravitational force that is applied continuously, and that is still applied when the body is at rest, and it is applied even when the rock is in his hand. But in this case, in the initial case and also at the last case, it is balanced by the normal force that is applied, or the reaction force that is applied upward. So those cases are static in equilibrium, but in the middle of that there is a net force applied throughout the path, this parabolic path. Throughout this parabolic path there is a net force, the gravitational force applied. So this kind of problem, which is in the middle after leaving the head and before touching the coming back to the ground, those kinds of problems will be dealing with in the dynamics section, where there is always a net force applied and it is trying to create an acceleration. So initially when it was moving up, there was an acceleration, and when it is coming down, there is an acceleration produced due to the gravity. So in that cases, we will be dealing with them in the dynamics section. These are the recommended books for this course. I'm following the ORC Hebilo Engineering Mechanics Dynamics 13th edition. You can choose anyone whichever is better for you. So this is the first lecture, the basic introduction for to the course. So I'll see you in the next video. Thank you and goodbye.